The structure of the Earth's interior is fundamentally divided into three layers: the crust, mantle, and core. Each layer has a unique chemical composition and physical state and can impact life on Earth's surface. The crust, the outermost layer, is thin and rigid, mostly made up of rocks with a density of 2.7 to 3.3 gram per cubic centimeter. The lithosphere is split between continental and oceanic crust. The continental crust is thicker and less dense than the oceanic crust. Beneath the oceans, the crust varies little in thickness, generally extending only to 5 kilometers. The thickness of the crust beneath the continents is much more variable, but averages about 30 kilometers. Under large mountain ranges such as the Alps, however, the base of the crust can be as deep as 100 kilometers. The layers of the Earth are separated from each other through a transition zone. These transition zones are known as discontinuities. There are 5 discontinuities or the transition zones. The discontinuity between the hydrosphere and crust is known as Conrad discontinuity. Below the crust is the mantle, a dense, hot layer of semi-solid rock approximately 2900 kilometers thick. The mantle, which contains more iron, magnesium, and calcium than the crust, is hotter and denser because the temperature and the pressure inside the Earth increases with depth. The rate of increase in temperature is 10 degrees Celsius for every 32 meters increase in depth. The structure of the mantle is mostly silicate, with the density ranging from 3.2 to 5.7 gram per cubic centimeter. The discontinuity between the crust and the mantle is known as Moravec discontinuity. The mantle is further divided into two parts: upper mantle and lower mantle. The upper mantle, that is 35 to 670 kilometers, contains the asthenosphere. When you go about 100 kilometers into the Earth, the temperature is already in the range of 450 to 900 degrees Celsius. The upper mantle has a density of 3.9 gram per cubic centimeter. The upper mantle and crust together make up the lithosphere. The asthenosphere, averaging 80 to 200 kilometers, lies beneath the lithosphere. It's part of the upper mantle. Unlike the rigid and brittle properties of the Earth's crust, the asthenosphere behaves soft and plasticky. The crust sits on the top of the asthenosphere, which is part of the upper mantle. The portion of the mantle that is just below the lithosphere and asthenosphere but above the core is known as mesosphere. The lower mantle, that is 670 to 2900 kilometers, represents a significant amount of Earth's volume. It contains about 56% of the total volume filled in the transition zone and upper core. The lower mantle has a significantly higher density than the upper mantle. It averages about 5 gram per cubic centimeter of mostly solid rocks. The discontinuity between the upper mantle and lower mantle is known as Rapiti discontinuity. At the center of the Earth lies the core, which is nearly twice as dense as the mantle because its composition is metallic and iron-nickel alloy rather than stony. The Earth's core is made up of two distinct parts, the outer core and the inner core. Seismologists suggest that the core is rotating faster than the mantle. As the Earth rotates, the liquid outer core spins, creating the Earth's magnetic field. The core is separated from the mantle by the Gutenberg's discontinuity. Earth's outer core is liquid with a thickness of about 2400 kilometers. It is composed mostly of nickel and iron with a density between 9.9 and 12.2 gram per cubic centimeter. Because the core is made up of metal, electrical conduction transfers from the core to the mantle. Earth's inner core is solid with a thickness of 1250 kilometers. The transition between the inner and the outer cores is 5150 kilometers beneath Earth's surface. At the center of the Earth, it is about 5500 degrees Celsius. Earth's inner core has the highest density at 12.9 gram per cubic centimeters. The discontinuity between the outer and inner cores is known as Lehman discontinuity. Lastly, the portion of the core that is just below the mesosphere is known as perisphere. So this was all about the interior of the Earth. See you in the next video. Thank you for watching.